So on the end of chapter 7 exam review, numbers 1 through 4 is the exact same thing that was on the mid-chapter 7 exam, and the review as well for it. You take the given trig function that they are starting you out with, you draw a right triangle in the quadrant they tell you to draw it in. This is saying you're between pi over 2 and between pi. That would be what quadrant? And if you forget, go to your unit circle, find pi over 2, find pi. So that would be quadrant, what? No, are y'all ignoring me or y'all don't know? It's quadrant 2, right? Pi over 2 is 90, pi is 180. Please don't get hung up on that part. Use your unit circle to find out what quadrant you're in. So then you're going to draw a right triangle in quadrant 2. Remember, it goes from the origin out and then collapses to the x-axis. They are giving you two sides by giving you the trig function to start with. The sides you figure out they're giving you is determined by which trig function it is. This is sine. Sine is y over r. If you forget that, you could look at the top of your formula sheet and you'll at least see that sine is opposite over hypotenuse. So opposite of theta is 4, hypotenuse is 5. You do have to find the missing side using the Pythagorean theorem. You with me, Luke? You also have to adjust it to make it what here? Negative. And this is a 3, 4, 5 triangle. But that would be negative because you're in quadrant 2, right? And then these first 3 questions are literally pulling the formula from the formula sheet, plugging in the fraction, and then typing it in the calculator. And this is where you get some ugly fraction answers. So the formula for double angle formula for cosine, you have 3 choices. I don't know why, but I chose this one. Doesn't matter which one you choose. So that's 2 times the cosine squared minus 1. The cosine is going to come from reading your picture. Cosine is adjacent over hypotenuse. So that'd be negative 3/5 right there. Then you go to your calculator and you type it exactly how you see it. And it's going to come to a fraction, which is negative 7 over 25. Then you repeat with sine. There's only one sine double angle formula. I need to plug sine in. Instead of looking at the picture and finding sine, go with the one they give you just in case you're having an off day. So this will be 4/5. And then cosine, we've already found it. It's negative 3/5. Type that in the calculator. Get negative 24 over 25. Tangent only has one formula. 2 tan over 1 minus tan squared. Tangent from here is opposite over adjacent. So opposite would be 4, adjacent would be negative 3. And I am running out of room, so I'm going to have to write it like that. Squared. Type that in the calculator and you get 24 over 7. Yeah. All right. Look at number 4. It says, in what quadrant is 2 theta, right? In what quadrant does it lie? How do I get the answer to that? Yeah, you're just looking at the signs. And I actually didn't even trick you on this one because I let cosine be the first question and sine the second question. You think of the last test, I was trying to trick you about putting sine first and then cosine to see if you just went with order. So what is the sign of the cosine double angle formula? It's negative. No matter what the number is, what's the sign of it? It's negative. So it's negative, and then what's the sign of the sine double angle formula? It's negative. Okay, so if we have negative, negative, we're in quadrant what? 3. Does that make sense? You should get 0 and 180. Did you get it? Okay. Did you get everything to one side? Okay. When you did that, I went to the right. Did you go to the right or the left? All right. I went to the right. So 0 equals this right here, sine of 2 theta, sine theta, and sine of 2 theta. This has a like term. Yeah, right here, if you say 4 sine 2 theta, and then come under its like term. Alright, so that's 0 equals, this just comes down because it's not a double angle. And then negative 3 plus 4 would be positive 1. Right? Yeah, you cannot really do anything with the sign of the double angle in there because in order to solve it, we needed to be basic trig, basic angle. So I replaced sine 2 theta with 2 sine cosine. Alright, 2 sine cosine. Now I'm in single theta, so that's good. We have 2 terms. What do they both have? They have more than that. Pull a 2 sine out. Now, that would leave a 1, which you're dividing, and then plus, and then this would just be cosine theta. Now, set them equal to 0. This ends up being sine theta equals 0, because 2 divided 0 divided by 2 is 0. This ends up being cosine equals negative 1. And that's why you get 0 and 180 as your answers. I've run out of room. So remember when you're down to that part, that's where you look at the unit circle and it's saying where is the y value 0 and where is the cosine value, the x value negative 1. And that's how you come to the answers that it's 0 and 180. It is. I feel like y'all did better with 7, 4, and 5, so why don't we go to the stuff that's from the first section, yeah, 1 through 3. So you have 3 questions to simplify. And then you have 2, 4, 6, 7 questions to prove. 3 questions to simplify where, you never know if you're done. You just have to clean it up as best as you can. I will say that number 23 and 25, try your best not to go look at the answers. As you're trying to do, Don't go to the answers until it's just you're absolutely, completely, without a doubt stuck, or maybe ask me for help. But 23 and 25, if you're simplifying those correctly, you should come to an answer that you're like, oh, I have to be done, because there's 24 comes down to a single trig expression. That's how you know you're done. 26, I worked the left-hand side. 27, I worked both. 28, 29, I worked the left. 30, I worked both. 31 and 32, I worked the left. Okay, so what did I end up saying? I said 27 and 30, I worked both sides. And I ended up in the middle at the same expression. But all of the others, I worked just the left side to end up to the right side.
What, did you work both on 31?
I did not. But I did say to myself, what is tan of the double angle? Like on 31. I worked the left-hand side, but I had in the back of my mind that this right-hand side, since that's a double angle, I had in the back of my mind that that's 1 over, what is that formula? 2tan.
Over 1.
Yeah, so this is ugly. So you really could work both here to clean that up, because that's ugly. That's going to be
I just keep changing.
There you go. That's going to be a keep change flip, which ends up being this. So I knew that if I got to that with the left-hand side, I was already done. So you could work both there. Trying to look and see. Guys, in these proving ones, that one, number 28 is the longest one. 28 has 1, 2, 3, 4, like 5 steps. All of the others have 5 or like less than 5. 4, 3. One of them has 2 steps. Okay. So I guess if you're just working through this and you come to one that you want me to work, then let me know and I can work it. Is that you? Do you need this? You can get back to it. Okay. Yep. 11. You should come to 3 answers. 11. So on 11, your first thing is to get everything to one side. Then it's really hard to proceed with a cosine in there and a sine in there. So, and one of the sine, because I already have a single cosine, I didn't want to do anything with the cosine squared, because they're already like terms, or not like terms, but you know what I mean. Yeah. Same trig function. So I took the sine squared and I changed it. I substituted from your Pythagorean identities. If you recall, sine squared plus cosine squared is 1. So if you cup game shuffle that over, what am I shuffling? I need sine squared. All right, so sine squared is 1 minus cosine squared. I plugged that in. Then that let me have 4 terms where 2 of them are now like terms, the 2 cosine squareds, so they'll combine. And then it's a solve by factoring. You'll be able to solve, it'll factor nicely. Number 10 is also solved by factoring. Number 9 is solved by square roots because you just have the single trig that's being squared.